topic today, where good success is possible. Okay, so simplified physics for SS1 syllabus is what we are first term. That is what we're still on. Okay, so the topic, this is the second lecture for SS1 student for first term, and this is what measurement. So what we are going to be talking about is measurement, fundamental quantities and units, derived quantities and units, sub multiples and multiples, systems of measurement, dimensions and importance of dimensions. So those are the things we are going to be focusing the lecture outline for today's class. Okay. So what is measurement and why is this measurement actually important? Basically, everything that you need to do for a sense of, for a bit of accuracy, there is a need for measurement. Now just imagine you there, as maybe your parents ask you, or you wanted to cook. Cooking food, you actually need measurement. Okay, how many cups of rice do I mix with how many cups of beans, and the ingredients combination, how do I do it? You will not just come and take maybe 7 Maggi cubes and put into the food. So you need measurement, and measurement is actually very important in physics. So in physics, what is measurement? So measurement are measurement. And why is this measurement actually important? Basically, everything that you need to do for a sense of, for a bit of accuracy, there is a need for measurement. Now just imagine you there, as maybe your parents ask you, or you wanted to cook. Cooking food, you actually need measurement. Okay, how many cups of rice do I mix with how many cups of beans, and the ingredients combination, how do I do it? You will not just come and take maybe 7 Maggi cubes and put into the food. So you need measurement, and measurement is actually very important in physics. So in physics, what is measurement? So measurements are very important in physics, as I've said, and other fields of science, because nothing can be done without telling accurate measurement. So nothing can be done without you knowing the accurate measurement of what you are doing. Measurements are useful by scientists. They are used by scientists and engineers as a means of communication for understanding natural phenomena. So what they understand by what measurement? So if I give an engineer a detailed diagram with dimensions measurement, the engineer will be able to interpret it perfectly without even seeing me. So now look at this example. James walks a distance of 30 every morning to school. Now if you look at that example, it does not make sense, because when we talk about measurement is not just giving just numbers. This statement does not make sense because it only gives us a number. So this 30 can be what? This 30 can be 30 kilometers, 30 centimeters, 30 anything. But one thing we have to know is that every measurement have two things. There must be a what? A quantity, which is the number, and there must be the basics by which the word measurement is what carried out. So every measurement must have those two. Those two are very, very important. They must have a quantity and what? A unit. So now let's go to what? Now what is a quantity? Quantity is the physical value we want to measure. So anything we want to measure in physics is actually called a quantity. In physics, we have two types of quantities, which are the fundamental quantities and what? Derived quantities. If you really want to understand some of this concept, it will be better for you to be able to make use of intuition. Now if you look at it, we have explained what quantity is. Fundamental, what is another word for fundamental? Fundamental means foundational, it means basic, it means elementary. So when we talk about fundamental quantities, we are talking about foundational quantities, we are talking about basic quantities, we are talking about elementary quantities. So when we talk about something being basic, something being foundational, it means that that thing is very, very important. So when we say fundamental quantity, by definition, these are basic foundational quantities upon which all other quantities are depending on. Just like the foundation of the building, physics is depending on these fundamental quantities. So without these fundamental quantities, the structure of physics will be what? Collapsed. So they are also called what? Independent quantities. Why are they called independent quantities? Because they are not depending on anybody. Every other person depends on them. So examples of fundamental quantities. So in physics we have 7 of them. So the first one is length, the next one is mass, the next one is time, the next one is electric current, the next one is absolute temperature, the next one is amount of substance, the next one is luminous intensity. So upon these 7 blocks is rise the entire physics. So these are the foundation of every other thing that we are going to be talking about in physics. So let's go to derived quantities. Derived quantities, so as the name goes, derive. So derived are those quantities that are depending on fundamental quantities. You can get them, you derive them by combining fundamental quantities. So just as you should know, derived quantities are many. So we have area, volume, we have weight, density, we have velocity, speed, we have acceleration, pressure, power, momentum, work and energy, we have electric potential force, we have moment, impulse, etc. So there are many. So all other quantities we have in physics are actually derived apart from those 7 fundamental quantities. So what are the difference between fundamental and derived quantities? So we have the table here. So fundamental quantities are generally accepted, derived are just accepted. They are based on international systems. So fundamental quantities are based on international system, derived are formulated from international system. Fundamental quantities can stand alone, derived cannot stand alone. So they have direct calculation, derived their calculation are derived. So fundamental quantities, they are basic unit of measurement, while derived are not basic units of measurement. So let's go to the next thing, which is unit. So because if you remember, we said that what every measurement must have a quantity and a unit. So what is a unit? A unit is what? The basis of which the measurement was carried out. Because as we said, every measurement is not complete without a unit. A unit is that basis of which the measurement was carried out, the basis at which that measurement was done. So we have 2 types of units, just like for the quantities. So we have the fundamental units, we have the derived unit. So what is fundamental units? So fundamental units, just the same thing. So they are also what? Basic units upon which other units depend. They are the unit of what? The fundamental quantity. So what it means is that just as we have 7 fundamental quantities, so we also have 7 fundamental units. So now let's categorize them. Now for length, the fundamental unit of length is what? Meter. For mass, the fundamental unit of mass is what? Kilogram. For time, it is second. Electric current is ampere. Temperature, it is what? Kelvin. Amount of substance, it is what? Mole. While luminous intensity is what? Candela. So those are their symbols beside them. So and one thing you should also note that fundamental units are also called what? SI units. So let's talk about derived units. So derived units are what? They are the units that depends on the what? Fundamental quantity. So sorry, that's supposed to be derived quantity. So derived units are those which depend on the fundamental units. So please, that is an omission there. So derived units are those that are obtained by simple combination of what? Fundamental units. So just as we have many derived quantities, we have many derived units. So these are the units. This is the table. So we have their derivation. Like you see area there, area is gotten by length times breadth. So the unit of area will now be length is measured in meter, breadth is measured in meter. So that is meter times meter to give us meter square. So volume is what? Length times breadth times height, which is meter times meter times meter, meter cube. So these are the what? Basic table. And one thing you should know is that there are some of these derived units that actually have to give them another name. Like you look at force in number 6. Force is what? Mass times acceleration. Mass is kilogram, while acceleration is meter per second square. So this name was now given as what? Newton, to honor Isaac Newton. And see the same for energy and work. Energy and work was also named after joules, while power was named after watts, while pressure was named after Pascal, and so on and so forth. So let's go to the differences between the fundamental and derived what unit. Okay. So for the fundamental unit, they are standard unit of measurement. So derived unit, they are not. Fundamental unit are what? Generally accepted all over the world, while derived unit may not actually be what? Generally accepted all over the world. So fundamental unit what? They form the basics of what? They form the basics of measurement. Derived, they are not the basis of measurement. Fundamental units are accepted by international organization. So although derived may be accepted internationally, but they were formulated by what? Individuals. So, and one thing you should notice that fundamental units are what? SI units, that is international systems of units, while derived are just what? Unit. So let's go to the next thing we are talking about, which is what? Multiples and submultiples. There are some times that what we want to measure, like length now is measured for in meters. There are sometimes that we measure things that are smaller than meter, and there are sometimes we measure things that are bigger than meter. So when we talk about submultiples and multiples, so submultiples are smaller values. Submultiples are smaller values, while multiples are bigger values of this unit. Now, if you remember, based on elementary school, they taught you something like millimeter, centimeter, decimeter, meter, kilometer, and the rest of them. Now you see that millimeter, centimeter, decimeter, they are smaller than what? Meters. So those ones are what? Submultiples. While kilometer, which is bigger than meter, is what? Multiples. So let's see the table. We have other things. It is not restricted to this. Like for the submultiples, we have decimeter, that is decim, centi. So you just have to add the unit at the back. So it can be decigram, it can be centigram. So we have milligram, we have micro is 10 raised to the minus 6, we have nano, we have pico, and so on and so forth. For the multiples, we have deca, hecto, kilo, mega, giga, tera, and we still have others. So now let's go to what we have. The next system of measurements. There are various systems of measurement, so system by which measurement is being carried out. So the most accepted one is the one we call the SI unit, which is called System International Units. So this is the one that is the most accepted today. It was formerly called what? MKS, that is meter, kilogram, second. So we have other system of measurement like CGS. So CDM means what? Centimeter, which is for length. G means what? Gram, which is for mass, and S means what? Time. So we have another one which is MKS. So MKS was the one that is currently being called SI unit. We have FPS. FPS is foot, pound, second. We have IPS, inch, pound, second. So we have those units like that. Okay, let's go to dimension. So dimension of a physical quantity is the best way, is the way that quantity is related, connected, or associated to the word fundamental quantities. So dimension is trying to relate a physical quantity to what? Fundamental quantity. Now basically among the fundamental quantity, we have the three of them that are the primary fundamental quantity, which is what? Mass, length, and what? Time. So for dimension, so the dimension of mass takes the what? First letter. Mind you, when writing dimension, you are not permitted to make use of what? Small letters. So it has to be a capital letter, uppercase letter. So the dimension unit of mass is capital M. Dimension unit for what? Length is capital L. Dimension unit for time is capital T. So now let's get an example. So this is example 1. So derive the what? Dimension for the following. So they ask us to derive the dimension for the following: speed, velocity, acceleration, force, and work. Now by the time you are solving dimension, there is a need for you to know the formula, the derivation of that quantity you want to derive the formula. the dimension for. Now let's look at speed. For example, solution. What is the formula for speed? I gave that earlier on. Speed is what? Distance over time. So distance over time. So we ask ourselves, what is the dimension for distance? Distance is a length, so the dimension for length is L, and time is time. So dimension for time is T. So the dimension for speed will be L over T, which is what? L raised to power T minus 1. So now we go to the velocity. Velocity is what? Displacement over time. Displacement is a length, which is L, and time is T. So that is L T minus 1. So both speed and velocity have the same what? Dimension. Now we go to linear acceleration. Linear acceleration is velocity over time. So we ask, okay, what is the dimension for velocity? We have just gotten it just now. So velocity is what? Lt minus 1. So divided by t, which is the time. So this is going to give us what? Lt minus 2. So this is from the knowledge of indices. Force is mass times acceleration. Mass is what? M. Acceleration, which we just finished getting, is Lt minus 2. So joining them together is mLt minus 2. While work is force times distance. Force is what we just derived now, which is mLt minus 2 times what? L. So the L now becomes double. So this is what? How we carry out what? Dimensions. Now let's go to example 2. Derive the dimensions of the following: power, pressure, momentum, impulse, and moment. Okay, let me see if you can be able to do that. You can pause the video at this point. Let me explain something. Now, power is what? Work over time. So see if you can be able to do it. We just finished deriving work, so divide by time. So get it done. While pressure is what? Force over area. So force, we derive force. Area should be L2. So just do the dimension of force divided by L square. Momentum is what? Mass times what? Velocity. So mass, we have mass there as m, and velocity, we have got to velocity. So just get the momentum. While impulse is force times time. Moment is what? Force times perpendicular distance. So let's see if you get it. So this is the answer for the first one, the answer for the second one, the answer for momentum, the answer for impulse, and the answer for moment. Were you able to get it? Okay, that's wonderful. Keep it up. So let's go to the importance of what? Dimension. What is the importance of dimension? So the first one is that it shows the correctness of a formula. So dimension helps us to know if this formula that we are given for the physical quantity is actually correct. Number two, it shows the relationship between the physical quantity with respect to the word fundamental quantities. So I hope with this class you have been able to understand a lot of things, talking about what measurements are, what is the fundamental quantities, what is the derived quantities, what is the difference between both of them and their units. We have been able to also learn about submultiples and multiples, where we say that multiples are the bigger values of the unit and submultiples are the smaller values of the unit. We have talked about system of measurements, we have talked about dimensions, and we are now talk about what importance of what dimension. So these are the exercises that you can use to like work it to be sure that you are actually understand what we have done in today's class. So thank you very much for listening today, and please, mind you, try to subscribe and invite your friends to join us in this wonderful journey. Thank you very much. I remain Oshe Baba, that is Oyaku Stephen Emeka. So God bless you. See you in the next lecture.